Okay. Today, I want to talk about the section 6.1, inverse function. Can I see the chatting box again? Okay, good. Okay, so this is like the first one, the section 6.1, the inverse function. This is something like outline. I want to talk about definition of a function, definition of a one-to-one function, definition of the inverse function, how to check if a function has the inverse function. The fifth one, how can you find the inverse function? The last one is, how can you find the derivative of the inverse function? I'm going to talk about 6 kind of things today. The first one, the definition of a function. The definition. The a function f from a to b is a relation that assigns to each element x in A exactly one element y in B. We call A the domain of F, B the codomain of F. I think if you turn on your video and audio, could you turn off your video and audio? Thank you. So what's f of a? The f of a is the all function values f of x such that x is in the domain of f, like a. So we call f of a the range of f. So this is example. The f of f is this kind of diagram, the one relation. This is my equation. So this is function. What do you think? This is a function. This is a function. Yeah, no. So one guy's no. So what do you think? Okay, yes, yes, yes. Okay. So let me see. The one important thing is 2 keywords. So each element x in A is going to exactly one element y in B. This is the definition. You choose 1. 1 is going to exactly one number 4. The 2 is going to exactly one number 6. The 3 is going to exactly one number 5. Yes, this is definition of a function. The answer is the function. F is a function. So what's the domain? Do you know what's the domain? Could you write the answer on chatting board? 1 through 3. Jesse, Alan, 1 through 3. Head and cramp. Okay, thank you, all of guys. Yeah, you're right. This is exactly 1 to 3. The A is domain. What's a codomain? So what's a codomain? Okay, right. 4 through 6. 4 through 6. It's good. But answer is wrong. So what is exact codomain? So you write 4 through 6 is range. Yeah, 4 through 7 is correct. So codomain is 4 through 7. So range is, you're right, the 4 through 6. 4, 5, 6, exactly assigned numbers. So next here, I want to give one more example. This is one relation f. So this relation is a function. So what do you think? This is a function or not? No, not a function, not a function, not a function. The only one guy said yes. The 2 guys yes. 3. Okay, most of the guys think that this is not a function. Unfortunately, this is a function. So why? So here, As I said before, like this. You choose any element in A, the 1 is going to exactly 1 number 5. The 2 is going to exactly 1 number 6. The 3 is going to exactly 1 number 5. It doesn't matter. 2 different numbers are going to 1 number. It's good. This is a function. This is a function. Yeah, you're right. Not a one-to-one. This is, I can talk later. Thank you, Miles. So here, domain of F is, what's the domain of F? Yeah, 1 through 3. 1 to 3, 1 through 3. Yeah, thank you, all of guys. Yep, the 1 through 3. The codomain is 4, 5, 6, 7. Yeah, 4 through 7. What's the range? What's the range? Yes, just to 5, 6. Yeah, just to assign the numbers 5, 6. That's right. Here exactly only assigned numbers 5, 6 is range of F. Exactly range of F. This is 5, 6. The next one. So this relation is function or not. Yeah, no, yeah. The other guys right. Yeah, this is not a function. This is not a function. It's not a function because this is the reason. 1 is going to 4 and 5. One number is going to 2 or 3 numbers, not a function. This is not a function. Okay, good. The next thing, I'm going to talk about one more important concept, one-to-one function. A function f is called one-to-one function if it never takes on the same value twice. That is, f of x1 is not equal to f of x2 whenever x1 is not equal to x2. This is the definition. So I'm going to give you an example. What do you think? So this function is one-to-one or not? Okay. Most of the guys' answer is yes, 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 yes. You're right. This is exactly one-to-one function because f never takes on the same value twice. This is one-to-one. So what's that? This is one-to-one or not? Yeah, no, no, no. Okay, thank you for writing your answers. Thank you very much. Yeah, this is exactly not one-to-one because f takes on the same value twice. So here, the 1 is going to 5. The 2 is going to 5. What does it mean? F takes on the same value 5 twice, not one-to-one. Not one-to-one. The next one. We have one geometric method. The if function f is one-to-one or not. We call it horizontal line test. So what's that? A function f is one-to-one function if and only if no horizontal line intersects its graph more than once. This is here. This is not one-to-one. Why? x1 is not equal to x2, but function values are same. F takes on the same value twice. So what does it mean? The meaning is like this. We can change it to the diagram. Here we have x1 x2. We can write this function value is like y1. So range has y1. What's that? x1 is going to y1, x2 is going to y1. F takes on the same value twice, not one-to-one. We have the two intersection point, the not one-to-one. We have two examples. F of x equals x squared. G of x equals x cubed. So first, we think about f of x. The function f is one-to-one or not. What do you think? Function f of x equals x squared is one-to-one or not? Okay, I can see your answers. Okay, the one guy is yes, other guy is no. Okay, let me see. So how can solve this problem? I will draw the graph. The graph is like this. F of x equals x squared. Graph is parabola. So like this. This is a function f, x squared. I can draw horizontal line. We have two intersection point. So what's that? Two intersection point. So not one-to-one. But what's G of x? Yeah, some guys right answer. Thank you. The G of x is like one-to-one because x cube is like this kind of curve. So like this is like G of x. You draw horizontal line. We have only one intersection point. Only one intersection point. So what does it mean? Yes, this function is one-to-one. But that's it. This is the idea for checking one-to-one or not from this example. The graph is like this. The next one, the definition of inverse function. F is one-to-one function with domain A, range B. What's the inverse function? We use notation f to the minus 1. We call the inverse function. Has domain B, range A. And it's defined by inverse of f of y equals x is equivalent to f of x equals y. What does it mean? You have to interchange domain and range. This is like idea. So exact diagram is like this. Right here. Was it like a function f? This one. X is going to y. X is input, y is output. Was it like inverse function? You have to interchange input and output. So here, input is y. Here, output is x. You have to interchange input and output. This is definition of inverse function. We have important results. The one good theorem. Function f is one-to-one, inverse function exists. Domain of inverse is exactly same to range of f. Range of inverse function is same to domain of f. So because the definition of inverse function is interchanging of input and output. This is the reason. The inverse of f of x is not equal to 1 of f of x. So really be careful. Don't write like this. The minus 1 is not a power. The not a power. We have two cancellation equations. Inverse of f of x equals x for every x in domain A. Inverse of f of x equals also x for every x in B. This is true. I can check first one. I can use this one here. F inverse of f of x. How can do that? Here. You can calculate f of x first by using this relation. X is going to y. We can write f of x is right y. Next one, we use inverse one. So y is going to x. So this is going to x. So what happens? Inverse of f and f cancel. So we call cancellation equations. So this is the reason. Okay, next one. To give some example here. The function f is like AB. We have inverse relation is like this. So what's like f? 1 is going to 4. What's inverse function? 4 is going back to 1. So 2 is going to 6. Inverse function has this result. So 5 is going to 3. 3 is going to 5 from f. The 6, sorry, this is 5 is going to 3 again. So we have inverse function. So we know function f is one-to-one, inverse function exists. This is very clear. The A is domain of f from here, the exactly same to range of inverse function, right? Here. This is domain of f is the same to range of f. So what's it like B? Range of f is the same to domain of inverse here. Range of f is same to domain of inverse. Next one, cancellation equation is true. Here. So what's it like f of 1? So 1 is going to 4. You can change 4. What's the inverse of 4? Here. 4 is going to 1. So change back to the 1. What happens? Inverse and f cancel. Like this. So this is true. The f of inverse of f 4. So similarly calculate inverse f of 4 first. Inverse f of is 1. Exactly f of 1. What's f of 1? We use function f. 1 is going to 4. So this is the same to 4. So what happens? Cancel. Cancellation equation works. So like this. So we have it. The next one. A is like this. Inverse function exists 1. What do you think? The function f is given. Inverse function exists 1. Okay, I see your answers. Okay, no, yeah, it's a good reason. Because not one-to-one. Thank you. No, not one-to-one. No, yeah. Are you guys right? Here, f is not one-to-one. F takes on the same value twice. So inverse relation is like this. So inverse is not a function because 4 is going to 2 numbers, 1 and 2. This is not a function. So inverse function does not exist. What's the remark? F is not one-to-one. We have this conclusion. Inverse function does not exist. So we have one important result here. If function f is one-to-one, then inverse function exists. If f is not one-to-one, then inverse function does not exist. You need to know this kind of result. The next tip. How can you find the inverse function of f? We have two methods. The one method is algebraic method. The second method is geometric method. What's like main key for finding inverse function? The main key is the next one. So really be careful here. Always interchange input and output. This is like the main idea for finding inverse function. This is main part. Interchange input and output. This is like the main things. You can think about algebraic method first. We follow 3 steps. Step 1, write y equals f of x. Step 2, solve this equation for x in terms of y. Step 3, interchange x and y. This is key. Interchange input x and output y. So the resulting equation is inverse function. This is algebraic method. What's a geometric method? Here, the graph of inverse function obtained by reflecting the graph of f about the line y equals x. What does it mean? Same. Interchange input x and output y. This is like the same idea. Here, this example, find the inverse function of f of x equals x squared plus 1. This equation. So what do you think? Inverse function exists or not? So before you find the inverse function, you have to check the f has inverse function or not. If function f has inverse function, you can find. The doesn't have it, you don't need to find. So what's the answer? No inverse function, no inverse function, no inverse function. Why not? Oh yeah, Jesse, it's a good answer. Without limiting domain, no, it's good. Yeah, one-to-one, it's good. Not one-to-one, without limiting domain, it's good. It's good. They're really good. Good answers. Yeah, this is not one-to-one because they're like this. You can draw y equals x squared plus 1. You can draw horizontal line like this. How many intersection points? We have 2 intersection points. So what does it mean? Not one-to-one. So what does it mean? Inverse function does not exist. So that's it. This is the whole idea. So answer is inverse function does not exist. So that's it. This is the idea. So Jesse said we can limit the domain. We have inverse function. This is like another example. Same function. F of x equals x squared plus 1. We can restrict the domain. X is less than y equal to 0. So what happens? The graph is like this. X squared plus 1 is parabola passing through 1, so like this. So what x is less than y equal to 0, you have to erase. So here, so like this, is right? You have to erase the right hand side, only left hand side. So what's that? You draw horizontal line. We have only one intersection point. The f is 1-to-1. So like this. 1-to-1 inverse function exists. I want to use 2 methods. What's the first method? Here, write y equals f of x. So we have y equals x squared plus 1. Step 2, solve this equation for x in terms of y. So how can do that? So like this. You have to subtract 1 from both sides. 1 is cancelled. So what's that? Here, x squared equals y minus 1. The next square root. What is x? So what is x? Put the square root, what happens? X is, you know, what is x? From the x squared equals y minus 1. The square root y minus 1. Okay. What do you think? You have the same answer? Square root of y minus 1. Is it right? Okay, just yes. Agree? Okay, yes, agree. Yes, yes. Okay. I'm going to give one example here. So we think about this one. What is x? What is x? 2, yes, plus minus 2. Yeah, this is very important thing. X squared equals 4. Answer is what? Plus minus 2. So here, take square root. What is x? Plus minus square root of y minus 1. We have this one. X is the square root of y minus 1 or negative square root of y minus 1. We have 2 possible answers. You can decide which one is x. Which one? Positive one or negative one? Which one? Positive one or negative one? Which one is answer? The negative one, the negative, positive, the negative, positive, negative, negative, negative. So let me see. Why do you think that answer is negative? Why? The why? Why do you choose negative one? Yeah. Yeah, this is a good question. X is less than y equal to 0. Reflect over y equals x is good. So x is less than 0, x is less than 0. Yeah, we have the 2 answers is good. So here, what's the domain? X is less than or equal to 0. X is what? Negative number. So you can choose negative 1. This is like idea. So we have it. Just negative 1 because domain. Because of the domain. X is less than or equal to 0. So step 3, interchange x and y. So what's that? You have to replace x by y, y by x. That's it. Y equals minus the square root of x minus 1. So like this. So this resulting equation is inverse of f of x. So next one, was it like a geometric method? The geometric method is like this. The graph of inverse of f is obtained by reflecting the graph of f about y equals x. So what's that? So like this. Here, the first two, you can draw y equals x first. The y equals x is this dotted line. This one. This dotted line is the y equals x. The next one, you reflect the graph of f about y equals x. Just reflect. So we have this one. Here, graph is like this. This is also 1. This is the inverse function. That's it. This is the idea. You can only match. This inverse of f is exactly same to negative square root of x minus 1. Here we have this kind of result. Okay. The Next one is the last concept. The last topic is the derivative of the inverse function. This is like last topic. So we are going to last one. What's the derivative of the inverse function? So we have one good theorem. If function f is one-to-one and differentiable function with the inverse function inverse of f, and f prime of inverse of f at a is not equal to 0, then the inverse function is differentiable at the same point a. We have this conclusion. Inverse of f prime of a is same to 1 over f prime of inverse of f a. So we have this one. So how can you find this one? This is proof. Proof not difficult. We can start definition. Y equals inverse of f of x. So we have this equivalent relation. You have to only interchange input and output. X equals f of y. Next, take derivative. The both sides. What is x prime? What is x prime? What is x prime? 1. Is right? X prime is 1. 1. 1. You're right. X prime is 1. What is f of y prime? What is f of y prime? So what kind of rule do you use? You can use chain rule. Is right? Here. Do you know this one? F of g of x prime is outer function prime of inner function times inner function prime. This is exactly chain rule. We use chain rule. This is idea. So what's that? The log of g of x is exactly y. The y is inner function. We have this result. F prime of inner function y times y prime. The next step is divide the both sides by f prime of y. F prime of y. What happens? F prime y cancelled. Y prime is 1 over f prime of y. We have it. So next, what is y? Y is inverse of f of x here. So you plug inverse f of x. This is exactly the y into here. You plug into here. Plug into here. We have this result. Last one, replace x by a. We have replace x by a. That's it. We have this result. This is the idea. We have it. So the last example here. F of x equals 2x plus cosine x, find inverse f prime of 1. So let me see. So if you want to find this kind of things, first you can check what? Function f is 1-to-1, 1. Function f is not 1-to-1. Don't use this theorem. So you can check function f is 1-to-1. Why do you check function f is 1-to-1? Because 1-to-1 function has the inverse function. This is the reason. You can check function f has inverse function 1. So this is the reason you can check 1-to-1. So f of x equals 1-to-1. What do you think? F of x equals 2x plus cosine x is 1-to-1? Do you have any idea? Do you know? This is true? Yes? Not 1-to-1? No, no, no. So yes, no. No? So I think why you answer is no, because cosine function. Cosine function is oscillating from 1 and 1 to minus 1, oscillating between 1 and minus 1. Was it like 2x? 2x is just increasing line. Increasing line. You can combine these two functions. What happens? 1 to 1. How can you know that? So I want to use one result from Math 140. Do you remember increasing, decreasing test? What is the increasing, decreasing test here? F prime of x is positive. What's the conclusion? Function f is increasing. Increasing. F prime of x is less than 0. Function f is decreasing. Function f is decreasing. This is like an increasing, decreasing test. So I wanna take derivative. F prime of x equals 2x plus cosine x prime. What is 2x plus cosine of x prime? What do you think? What's 2x? Yeah, 2 minus sine x. 2 minus sine x. Right? 2 minus sine x. Okay. Yep. Okay, good. The 2 minus sine x, you're right. The 2 minus sine x is answer. I can check. 2 minus sine x is positive or negative? The 2 minus sine x is positive or negative? Which one? Negative, positive, 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 positive. What's OS? Yeah, positive, thanks. Positive, yeah, positive. The positive, yeah, positive. The because this is the reason. So what's that? The negative sine of x is always between minus 1 and 1, oscillating between 1 and minus 1. You add it to each side. You add it to each side. So what happens here? Minus 1 plus 2 is 1. The middle one is 2 minus sine of x. Last one is 3. So always positive between 1 and 3. This is always positive number. So function f is increasing. So one more question. The increasing function is always 1 to 1. Is it right? So what do you think? The increasing function is always 1 to 1? Yes or no? Answer is yes. You're right. The y here I can draw. Was it like an increasing function? Here. This is like a graph is increasing function is like this. You can draw horizontal line. We have only one intersection point. One intersection point. One intersection point. So what does it mean? Always 1 to 1. So what's that? Function f is 1 to 1. Yes, increasing function is always 1 to 1. We can use conclusion of the theorem. What the theorem? Inverse f of prime of 1 equals 1 over f prime of inverse f of 1. We can use this one. The first one. You're right. So f prime of x is always negative. Graph is always decreasing. The decreasing graph is always 1-to-1. It's a good point. Thank you, 12 guys. Answer is right. The question is good. Thank you. So next one. Here, first, I want to find inside one. Here, this is the first one. The step 1. I want to find inverse of f of 1. I can calculate this one. Step 1, find this one. This is like unknown. I can write inverse f of 1 equals x. How can you calculate? I want to use definition of inverse function. Remember this one? Inverse y equals x exactly same to y equals f of x. I want to use this relation. So you plug 1 into y. So we have this one. 1 equals f of x. What's it like f of x? F of x is here. 2x plus cosine of x. How can you find the answer? How can you find this kind of answers? How can you find? Guess. This is good method. It's not easy to solve this equation for x. It's really difficult. Only guess. So which number satisfies this equation? 1 equals 2x plus cosine of x. This is my equation. What is x? 0, 0, 0, 0, 0. Yeah, this is 0. Thank you, all of guys. So y? So here, this is 0. How can you know that? You plug 0 into x. So what happens? 1 equals 2 times 0 plus cosine of this plus cosine of 0. So 2 times 0 is 0. Cosine of 0 is 1. Yes, 1 equals 1. So x equal to 0. So what does it mean? We have this one. Here, x is what? 0. So you plug 0 into inverse of f1. So we have like this. 1 over f prime of inverse of f1 is 1 over f prime of 0. The next step is you need to find f prime of 0. How can you f prime of 0? We already have f prime of x here, f prime of x. You plug 0 into x here, exactly 2 minus sine of 0. 2 minus sine of 0. What's the sine of 0? 0. The 0, 0. You need to know the sine of 0 is 0, cosine of 0 is 1. You need to know these two things. Sine of 0 equal to 0, cosine of 0 equals 1. So this is 0. So 2. So what is answer? So answer is like this. What's that? 1 over 2. But that's it. This is the whole idea. This is step 3. So 1 over 2. So that's it. We already follow 3 steps. Okay, so this is like a 2-day lecture. So do you have any question? If we have any question, just write your question on chatting board. I answer your question. If you don't have any question, you can leave. The online class. Yeah, I'm just waiting. If you have any question, just write anything. Oh, you're welcome. So the any question, no problem. If you try to solve some suggested homework or some exercise problem, just let me know. I can explain. Yep. Okay, you're welcome. Oh, web assigned question. If you have the web assigned question, it's good. Maybe just only write on the discussion board. The discussion board. So I don't give exact answer of the web assigned problem, but I can deal with similar problem on discussion board. This is possible. I can write the procedure and answer of the related problem. One example is f of x equal to 2x plus cosine x, find inverse f of prime 1. I can solve the f of x is 2x plus sine of x, like very similar problem. The very helpful. You can only write your question on the discussion board. I answer. I was answer to your question. Okay, thank you. Thank you all of guys. Thanks. Yep. Okay, thank you. Good night. Okay, you're welcome, all of guys. Yep. It's good. It doesn't matter. You can use don't use y prime, use dy with dx. It's good. It's good. Yeah. Though sometimes y prime is very confused, not explicit form. You can use dy with dx. It's good. Yeah, it's good. No problem. You can use it. Yep. Yeah, you're welcome.